AP Calculus AB, Unit 9, Day 10, Unit 9 Review Extra. I guess I'll show the answers right here real quick. You can pause the video if you need to. This is both the front and back page answers. So I'm trying to zoom out. Okay. So here is 1AB, 2, 3, 6AB, 7, 8, 9. Scoot it up in a second and pause the video. So here are the other answers. Pause the video, check your answers. Okay. Let's see. Okay, first one's a little extra practice with approximations of definite integrals, either Riemann sums, which are rectangles, or trapezoids. We're going to use all the values here. Trapezoidal, I'm going to draw a quick picture just to organize information. 2, 6, 9, 11, 3, 5, 8, 4. So trapezoids just connect the endpoints. These are usually the bases of the rectangles, but these are going to be the heights of your trapezoids, and they're not all the same. So the integral of 2 to 11 of f of x dx is approximately, areas of trapezoids are just like areas of rectangles, base times height. There's two bases, you average them. 3 plus 5 over 2 times height, 4. 5 plus 8 over 2 times the height, 3. 8 plus 4 over 2 times the height, 2. So we're going to get 16 plus, this is 13, 39 halves plus 12. So if we give these least common denominators, get 32, 71, 95 halves, or 47 and a half. So the integral 2 to 11 of f of x dx is approximately 95 halves, which is also the same as 47 and a half. Okay, next one, I'm going to draw a new picture. And it's all the same values as the last one. Right endpoint, so we're using the right side as the height of each slice. So the first left side doesn't get used. These are now the bases. So 2 to 11 of f of x dx is approximately base times height, 4 times 5, base times height, 3 times 8, base times height, 2 times 4. So it's going to be 20 plus 24 plus 8. It's going to be 52. So 2 to 11 f of x dx is approximately 52. So that's the kind of work I'm looking for. Next ones are integrals of absolute values. So this one we could do 3 different ways. So I'll go and show you all 3 different ways. It's linear, so we could use geometry. So I'm just graph it without the absolute values first. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And then the absolute value flips the negative part up. And you get a V graph. And we want from the area from 0 to 4. So that's going to be a big triangle plus a little triangle, You don't have to write this, but I'm just going to write it. So it's going to be 1/2. The base of the first one is 3, and the height is 6, plus 1/2. The base of the next one is 1, the height is 2. So that's going to be 9 plus 1 is 10. So that's one way to do it. The other way is find the zeros, so factor it. And that's where we're going to split it up. That's where we end up splitting it up anyways with the geometric approach, but probably didn't think as much about it. So the table, I'm going to say, all right, 0, 3, 6, 4, and we're going to integrate 2x minus 6 without absolute values. So it's going to be 2x squared over 2 minus 6x plus c. So plug 0 in there, we get 0. Plug 3 in, you get 9 minus 18 is negative 9. Plug 4 in, you get 16 minus 24 is negative 8. And we find the distance, 9, 1. We add them up. 9 plus 1 is 10. So that's kind of a nice way of doing it. Otherwise, you can kind of do it more of a just straight out long version. So you would do a line check with your 0. And it's going to be positive, negative. And so then you rewrite it and you say, okay, we're going to do 0 to 3, drop the absolute values, 2x minus 6. And then we're going to do 3 to 4, 2x minus 6. And if it's negative, we've got to fix it with an extra negative in front to force it to become positive. If it's positive, just leave it, plus. So then we're going to do 2x squared over 2 minus 6x, 0 to 3. This is going to be the same antiderivative, so don't think too hard about it. So then we plug 3 and we get 9 minus 18 minus 0 minus 0. And here we're going to get 16 minus 24 minus 9 minus 18. So this is going to be negative 9. Negative is going to become positive 9, which it should become. This is negative 8 minus negative 9. So it's going to be positive 1. And the answer is going to be 2. Same answer, different way of doing it. So any of those ways would work on the test. Next one we cannot do using geometry because it's not linear. So we've got to find the zeros no matter what. Don't need the line check for the table approach unless the answers are hard to figure out. But we're going to integrate the function without the absolute values. So we're going to get x cubed over 3 minus 4x squared over 2 plus c. We're going to do 0, 4, and 6. Plug 0 and get 0. 4 in, you're going to get 64 thirds minus 16 64 halves. So least common denominator would be 6. So that's going to be 128. You're going to get negative 64 over 6. So that's going to be negative 32 over 3. Next one, 6, is going to be 72. 6 times 6 is 36 times 9, 2 is 72. Minus 2 times 36 is 72. So that's going to be 0. And then you'll find the distance between them, 32 thirds. 32 thirds. So you add 32 thirds and 32 thirds together, you get 64 thirds, or 64 thirds, or 21 and 1/3. So that's one way to do it. The other way is you could then do a line check. Test x equals 5. Positive, negative, positive. You're going to rewrite it. You're going to say, okay, well, let's do 0 to 4. Drop the absolute values, x squared minus 4x dx. And then we're going to do 4 to 6, x squared minus 4x dx. Any negative parts have to be fixed with an extra negative in front. Positive parts stay the same. Negative antiderivative is going to be x cubed over 3 minus 4x squared over 2 The integer is the same in both of them, so this is going to be x cubed over 3 minus 2x squared also. I'm going to start plugging these values in. So this is going to be 64 thirds minus 32 minus 0 minus 0. And this is going to be 72 minus 72 minus 64 thirds minus 32. Okay, so least common denominator could be a 3. So it'd be 64 minus 96 is going to be negative 32 over 3. And this is going to be, this common denominator be 3. 64 minus 96 is going to be negative 32 over 3 also. So this will become plus, and we get 64 thirds, or 21 and 1/3. So 2 different ways of doing the same problem. Okay. Got lots of options. Okay. Next one. Next one, you're not going to do it with geometry. We do it with the table or the other way. So we're going to want to set this equal to 0. So cosine 2x equals 1/2. Alpha equals pi over 3. Quadrants 1 and 4. So 2x equals pi over 3 plus 2 pi k. And 2x equals 5 pi over 3 plus 2 pi k. Divide by 2, divide by 2, divide by 2, divide by 2. X equals pi over 6 plus pi k. X equals 5 pi over 6 plus pi k. We only want the values from 0 to pi, so that's going to be pi over 6 and 5 pi over 6. Now, even if you're going to do the table, you're definitely going to want to do a line check, because it's going to get confusing with the weird answers you get. You don't have to, but I think this is your best option. And it's not that much extra effort that you guys should be good at anyways. Cosine 0, so it's going to be positive, negative, positive. So for the table, we're going to integrate 2 cosine 2x minus 1. That's going to be sine 2x minus x plus c. The extra 2 is going to come out. We actually want that 2. So however you want to figure that out, you do use substitution, whatever. 0 pi over 6, 5 pi over 6, pi. So if we plug 0 in, it's going to be 0. Pi over 6 is going to be sine pi over 3, which is root 3 over 2, minus pi over 6. 5 pi over 6 is going to be sine of 10 pi over 6, which is 5 pi over 3, which is negative root 3 over 2, because it's in quadrant 4, minus 5 pi over 6. And pi, sine 2 pi is 0, minus pi. Now this is where it gets weird, because if you want to find the distance between these, if these are just numbers, just rational numbers, we'd probably just do it in our head. But here, if it's positive, you want to do this minus that. So this is going to be root 3 over 2 minus pi over 6. That should for sure be the positive difference. Next one is negative, so you want to go backwards. You're going to do this one minus this one. So then if you do that, you can get root 3 over 2 minus negative root 3 over 2 is going to be 2 root 3 over 2, which is going to be root 3. And then negative pi over 6 minus negative 5 pi over 6 is going to be plus 4 pi over 6. And then the next one is positive, so we're going to do negative pi minus this. So if you do that, it's going to be negative pi. You're going to get positive root 3 over 2. Negative pi plus 5 pi over 6 is going to be negative pi over 6. So if you add all these together, you're going to get 2 root 3 plus 2 pi over 6, which is pi over 3. So that's the answer that way. Otherwise, the other approach is to rewrite it and say, okay, you would do all this work still, either way you do it, but then there's the table, and then there's the other way of saying, okay, we're going to do 0 to pi over 6 of 2 cosine 2x minus 1 dx. And then you're going to do pi over 6 to 5 pi over 6 of 2 cosine 2x minus 1 dx. And then you're going to have to do 5 pi over 6 to pi of 2 cosine 2x minus 1 dx. I mean, this is going to be a lot of work. The negative part you got to fix. So this one needs a negative. Otherwise, the other ones are positive. And then you're going to just keep going with that. So I'm not going to show that. I'm just going to let you guys work that out if you want to try that. Now, number 5 does not have absolute value. So please don't make it some crazy hard problem and get it completely wrong, because it wasn't. Now, this, you could do u substitution. U equals 2x. D equals 2 dx. Don't want the 2. Here's a couple things. One, I think we totally pulled this off without u substitution. This should not involve the u substitution. So we're going to do this guy on its own. Whether you rewrite it or not, that's up to you. Okay, and so that's going to be x squared over 2, 0 to pi. But I think we could jump directly to the antiderivative sign is going to be cosine. And this is going to give me an extra 2 in front that I don't want. It's got to be negative. So, I mean, I feel very comfortable with that. Otherwise, you could do u substitution. You get 1/2 sine u du, which is going to give you negative 1/2 cosine u. And then you got to plug this back into there, and you're going to get where I got anyways. So that's up to you depending on your level of comfort. This is going to be pi squared over 2 minus 0 plus, it's going to be negative 1/2 cosine of 2 pi is 1 minus negative 1/2 cosine of 0 is 1. So this is going to be pi squared over 2 minus plus plus. It's just going to be pi squared over 2. That's it. So don't turn that into an absolute value problem if it isn't already. I mean, I don't know. I guess I could. I don't even want to try this work. I'll do it anyways. Okay, so I'm going to finish number 4. So we're going to get sine 2x minus x, 0 to pi over 6, minus sine 2x minus x, pi over 6 to 5 pi over 6, plus sine 2x minus x, 5 pi over 6 to pi. And then you guys start plugging stuff in. Sine of pi over 3 is root 3 over 2 minus pi over 6. And then you got to plug 0 in. 0 minus 0. So that's the first one. Minus sine of 10 pi over 6 is going to be negative root 3 over 2 minus 5 pi over 6 minus sine of this is going to be root 3 over 2 minus pi over 6 plus sine of 2 pi is 0 minus pi minus sine of 10 pi over 6 is negative root 3 over 2 minus 5 pi over 6. Oh my goodness. That's horrible. I mean, you gotta be very careful. Oh my gosh. Okay. This is gonna be so what we got? We got root 3 over 2 minus pi over 6. This is going to be negative root 3 over 2, negative root 3 over 2, negative 2 root 3 over 2 is going to be negative root 3, but then you got to apply this negative, so it's going to be plus root 3. And you have negative pi over 6 minus negative 5 pi over 6, so it's going to be negative 4 pi over 6, but then it's going to be plus 4 pi over 6. And this one's going to be negative pi plus pi over 6, so it's negative pi over 6, and plus root 3 over 2. So then you're going to get root 3, or 2 root 3, and then plus 2 pi over 6 is plus pi over 3. So same answer, ton of tedious work. We can do the table. Now the table's not super easy either. You got to be really careful with the table. That's where the line check really comes into this table because of all those irrational answers. So on the back, we got a little distance displacement stuff. So we definitely need displacement is the integral of velocity from 1 to 6. Okay, distance is going to be the integral of the absolute value of velocity from 1 to 6. We've got to find velocity. So I guess I'll do that right here. Velocity equals the integral of v prime equals the integral of a equals the integral of 2t minus 2 dt. So velocity is going to equal 2t squared over 2 minus 2t plus c. We got to find plus c, use initial condition, plug 0 in. And it equals 0. So our velocity equation is officially t squared minus 2t. So I think we should do a table. Well, one, we got to figure out where this equals 0. Got to find the zeros. Okay. We could do a table and find both of these answers in the table very nicely. So 0, integral of velocity, integral of t squared minus 2t. It's going to be t cubed over 3 minus 2t squared over 2 plus c. We're going to plug in 0, 2, actually, we're going from 1 to 6. So 0, 1, 2, 6. We don't need the 0 one because it's outside the limits. Plug 1 in, get 1/3 minus 1, which is negative 2/3. Plug 2 in, get 8/3 minus 4, which is negative 4/3. Plug 6 in, 72 minus 36 is 36, or 108/3. So displacement is really just going to be the last one minus the first one. So that's going to be 110/3, or 36 2/3. So that's displacement. Distance is just going to be all these distances out of. That's going to be positive 2/3. It's going to be 112/3. So distance is going to be 114/3, which actually is a nice answer. It's 38. Otherwise, you could do it the long way without a table of the integral of absolute values. Have fun. Same thing here. We could do this one totally separate. But the table is cool because you can use it for both answers. Just make sure you know what you're doing. And I guess if you really had to, you can fall back on that other approach. Okay, mean value theorem, but not for derivatives anymore, for any function, which also includes derivatives. Average value, mean value, same idea. Don't memorize this equation. Remember this idea. I'll draw it one more time. We have a curve. We want to find the average value, the average y, and it'd be somewhere in here. So our strategy is find the area under the curve, smooth it out into a rectangle, divide by the base of the rectangle, you get the height of the rectangle. That's what you're looking for. So f average is, and that's the way I think it was. I'm like, okay, well, let's find the area under the curve, and let's divide by the base of the rectangle after we smooth it out. That's it. That's the strategy. So now we just got to pull it off. 3x cubed over 3 minus 2x squared over 2, 1 to 4. So it's going to be 64 minus 16 minus 1 minus 1. It's going to be 1/3 of 58, 48, which is 16. then you might have to find the c values, right? Which you weren't asked to here, but if you had to find the c values, you take the original function, 3x squared minus 2x, set it equal to the average. C values are the place where the actual function equals that, and then you would go through and start trying to solve it. I'm not going to finish this, you weren't asked to, but this is what you would do, and you just got to finish the algebra. B, find the average value of Johnny's acceleration. Well, if this is his, now there's two ways to do this. The easier way would be like, okay, well, average acceleration is going to be the velocity at 6 minus the velocity at 2 over 6 minus 2. This would be slope of the velocity curve. It's average derivative. But you'd have to get the velocity equation. So that'd be t squared minus 2t. And then we'd plug 6 in here. It'd be 36 minus 12 is 24. Minus 4 minus 4 is 0. So it's going to be 24 over 4 is going to be 6. So that's I think, the best way to do it is to use mean value theorem for derivatives, since it is a derivative. But you could keep going and find the acceleration function. It would be 2t minus 2. And you could find the average acceleration by integrating the acceleration function, finding the area under the acceleration function from 2 to 6, and then divide by the base of the rectangle. Do it that way. Unfortunately, what you're doing is you took the derivative to get acceleration. Now you're undoing the derivative essentially to get back to velocity. So you did work, and now you're undoing it. And then we're going to do the same exact work that we're doing here. I'm going to plug 6 in here. 36 minus 12 is 24, minus 0 minus 0 is 0. Right? We're getting the same numbers we got up there. We did extra work, though, to get to them. But either way, if it is a derivative, I think that mean value theorem for derivatives that we learned before in previous units is easier. Fundamental theorem of calculus. Well, f prime equals f of x. So this is actually f prime of x here. So I've given you the integral of f prime, and I've given you the value at another place. I want you to find another one. Well, that's perfect opportunity for fundamental theorem of calculus part 1. That says if you integrate a derivative, you get the original function. Then if we plug in the limits 3 and 10, we plug in limits here. So use the one you know and the one you're looking to find. Do smallest to biggest. We want to keep things as least complicated as possible. So then we could solve for f3. It's going to be f10 minus 3 to 10 of f prime of x. It's good to show me your setups, because after that we're just plugging stuff in. F of 10 is 2. That was given to you as 20. So f3 equals negative 18. Number 10 is the same idea, but you're going to have to get the integral of the derivative a little differently. Instead of me just giving it to you, you're going to use the graph of it and find area under it using geometry. But we should set it up. F prime of x, if we integrate f prime of x dx, we get f. We're going to go 2 to 8. So we get f of 8 minus f of 2. I'm trying to look for that. So I'm going to solve for it. F2 equals f of 8 minus the integral of 2 to 8 of f of prime x dx. F of 8 is given to you as 40, and this is going to be the area under this graph from 2 to 8. However you want to find that. There's a triangle here, which should be 1/2 base. Be careful, these increments are 2 each. These ones are actually 4 each. 1/2 base. The height is going to be 6. So that's going to be 6. This you can do as a trapezoid, unless you won't want to break into rectangle triangle. That's up to you, but trapezoids is going to be quicker. And you should feel comfortable with trapezoids. This base is 4. This base is 2. It's the average of the bases, 4 plus 2 over 2, times the height, which is 12. And so that's 36. This whole area right here is 36. You could get it by breaking it up more. So it's going to be 42. So the answer is negative 2. All right, and then fundamental theorem of calculus part 2. You guys should love these problems. These should be the quickest problems in the whole test. But also, if you don't know what you're doing, you're going to totally get them wrong. So derivatives undo integrals, plug limits in, but top first, bottom second, you got to subtract. Okay, but then you got to multiply by the derivative what's inside that you plugged in inside, because we haven't finished the chain rule yet. So it's a big chain rule. So if you just plug in a constant number, that term is going to go away. So we can get negative 2x sine of x to the 8th. Show your work. Okay, this one, derivative undoes the integral, plug limit in. But I'm usually just careful with this, so it's going to be the square root. I'm going to leave a little extra room here. Square root of 1 plus 2 e to the 2x cubed minus 1 plus 2x squared cubed. I got to multiply by the derivative of what I plugged in, so that's going to be a 2e to the 2x. And that's going to be a 2x, just what you plugged in. Everything else has been taken care of. 2e to the 2x square root of 1 plus 2e to the 6x. Let's simplify it. Minus 2x square root of 1 plus 2x to the 6th. That's your answer. Okay, hope you guys ready. Some good extra practice for your test.